you're going to get x. This is essentially the same problem, minus 2. And this is going to be x equal minus 2/3. Now you got to think about this a little bit, because it doesn't hang together quite so easily, right? And to make sense of this, the easiest way is to do a numbering line, put a 0 here. Yeah, okay, I did that right. So find what's the most negative number. Yeah, it's way out over here. And which way am I walking? What does it tell me the x value is going to be? All right. Okay, and then x is, 2/3 is smaller or closer. Okay, and it's got to be greater. And I see, there it is. There's why it's an or statement. You see there's a hole in the middle? So its solution set goes from negative infinity to minus 2 in union with minus 2/3 to positive infinity. I know I always get round brackets, but where do I square or round? Square. Square brackets, okay? So I'm going through the classic kinds of problems. On your quiz, they may give you something a little more complicated, because on your quiz you've got a lot of time. On your test in class, I usually tend to give actually algebraic, fairly easy problems, because I can give you more of them, if that makes sense. Yeah. By which direction this faces. That's the only tip-off. Yeah. Now there's some other twists and turns to doing this we didn't talk about in class, but I don't want to make you the world's greatest inequality solver. I want you to understand the basics, because you're going to see these things again when you go on to calculus, and I want you to understand what they mean, because you'll have to look at it from a calculus viewpoint. Okay, 2065. We're done with this one. You remember what it is to have an even or odd function? We're going to talk about this in trig in our class, so it'll become important for you to be able to see some patterns. Algebraically, you can always remember an even function. I always remember it this way. Y equals x squared. And an odd function, I always just remember it as y equals mx plus b, because that's to the first power. And you could see right away that this has a reflection this way, right? And this has a reflection this way. Now there are other kinds of symmetries, by the way. There's symmetry about the x-axis. That doesn't turn up so much, and it's not that important. For the class we just got out of an hour earlier, for my Monday, Wednesday class, remember there was some symmetry that went this way. There's all kinds of symmetry, but the two biggies are this even and odd. How do I check that algebraically? You take your function here, you put a negative x in it, or you take a function here and you get back the function x with a complete negative sign. Okay? If you have either of those two cases, you know you have an even or an odd. So let's check this thing. Let's search and see if I have no idea what it graphs like, so let's search it and see what it looks like. Yeah, question?
What do you mean by complete negative?
Say that again?
What do you mean by complete negative sign?
Let's look at it. Let's check it for even. We're going to grab this. This is what the function normally looks like. Normally it looks f of x, x cubed minus 27. All right, I need to take f of minus x equals minus x cubed, well, minus 27. And when I do that, what do I get here? I get negative x cubed minus x cubed minus 27. All right. Now I compare it. If I'm going to say that this is even, I should have got back this function right here. When I put a negative x in here, I should have got back x cubed minus 27. Nope, doesn't look like that. It's not an even function. Okay? It doesn't have this property. That's what that tells me. Okay? Let's check if it's an odd function. If it's an odd function, I should get back this, which would be a minus x cubed. Minus a minus is a positive 27. Is it odd? Yep, it's neither. It's neither, okay? So it doesn't have either odd or even symmetry. Okay? Yeah. Simple check. So just know how to do that and know what that means. Okay, so that was 65. Okay, we can do more if we have time. Okay, so this is a function. It's in pieces, right? And we want to be able to sketch this. Now, again, on the test, on your quiz, you're definitely going to see something like this. On your test, maybe I don't do so much sketching. Why? Because you got your fancy calculator. How boring. Right? You would put in the card, it's too easy. But I might ask you some questions about this. But let's go through it as though we do want to sketch it, okay? So when I look at this, I see this piece here. This looks to me like y equals x plus 1. This piece looks like y equals x squared. So I'm going to sketch it. Let's see, x squared. I know what that looks like. It looks like this. This is y equals x squared. How am I going to graph that piece? What point do I know for sure? 1 is the what? Yeah, positive 1 right here. I know I got that. And it's a positive slope, so I go out here 1, I go up 1. Okay, it looks like that. Okay, so now I got to think about the domain here. This is only good when x is less than 0. So x is less, this doesn't exist here. X is less than, actually there's a hole here. Okay. And this is good, x greater than or equal to 0. So there it is. And this doesn't exist here. All right, now I got my function. That's what it looks like. Is this continuous? No, it's not continuous. It has a jump to it. Okay.